we continue with the convolution of two functions. So remember, this is what we had in the previous video about the convolution. We have two functions, f and g. We talked about the definition of the convolution, and the motivation behind it was, in fact, this formula here. So the question was, what is it? What is it? That function whose Fourier transform is the product of the two Fourier transforms of the two functions. And of course, for a beginner, we would say, okay, take the product of the two functions, then we discovered that the product is not true. So it turned out that the convolution is the function that we are looking for. So we defined the convolution by this integral we have here. And after defining the convolution, we had this formula about the Fourier transform of the convolution, where we had that the Fourier transform of the convolution is the square root of 2 pi times the product of the two Fourier transforms. Then we had these basic properties, a graphical interpretation, and an example. Now I would like to have two more examples about the convolution. And as you've seen in the previous video, the computations of the convolution are not very immediate. We have sometimes delicate computations, so we need to familiarize ourselves with these computations. Okay, so as usual, when we talk about Fourier transform, we need to have functions that are integrable on the real line. Those functions cannot be polynomials. We're not talking about sines, cosines. So these functions are selected very carefully to have them integrable on the real line, like the function e to the minus x, like the square or the rectangular function. Okay, so in this example, I'm going to take the function, so f of x be e to the minus absolute value of x. Again, this function is an L1 function, it is integrable. And let's find together f convolved with f. Remember, in the previous example, what we found was the convolution. So this function here in the end of the computations, we found the convolution of the function e to the minus x convolved with, let me do it this way, the rectangular function, which is 1 over the interval -1 and 1, 0 outside that interval. Okay, so in this example, I want to find the convolution of this function with itself. We start with the definition. So what's the definition of the convolution of any function with another function? In this case, it's the same thing. So it's the integral from -infinity to infinity. In one of the functions, we just replace x by t, and in the other function, we replace x by x minus t. But in my case, the functions f and g are the same, so basically I don't have f times g, I have f times f. So this is the integral from -infinity to infinity. What is f of t? It's e to the minus absolute value of t. And f of x minus t, it's e to the minus absolute x minus t dt. Now, again, the variable of the integral is t, is not x. And the t is running over the interval from -infinity to infinity. So basically, half of the interval is composed of negative values, so this is 0. So when t is here, the absolute value of t is -t. When t is here, the absolute value is t. So basically, for this integral, we need to split it from -infinity to 0. And in that case, the absolute value of t is -t, so e to the minus absolute t is t times this. Then plus from 0 to infinity, e to the minus t, e to the minus absolute x minus t dt. Okay, so this is our convolution. So now we need to get rid of the other absolute value. So for e to the minus absolute value of t, so the first integral, for the first integral, this thing here, we got rid of the absolute value. But now we need to get rid of this absolute value, okay? We need to get rid of these two absolute values. So how are we going to do that? It is very clear that getting rid of the absolute value depends on the comparison between x and t, because again, the absolute value, what do we mean by the absolute value of x minus t. This is either x minus t when x minus t is positive, and x minus t but negative, plus when x minus t is negative. So that's basically x minus t if t is less than or equal to x, and t minus x if t is bigger than or equal to x. And remember, in doing the convolution, so the variable of integral is t, and the x, just imagine the x as a fixed value. So imagine, for example, x is 1. So if x is 1, what does this say? This says x, which is 1, minus t when t is less than or equal to 1, and t minus 1 when t is bigger than or equal to 1, right? So for example, if you look at, so let me erase this stuff here. I think now it's very clear. Okay, so the idea now, I will do each integral individually. Okay, so for the integral from negative infinity to 0, e to the t, e to the minus absolute value of x minus t dt. Okay, so let's do this integral first, and after doing this integral, I'm going to do the other integral. Okay, so in this integral, because the variable of integration is t, and the limits of the integral are from negative infinity to infinity, so basically what we're saying is that these from negative infinity to 0, so these are the t values. Okay, now just imagine this. X is a fixed value, so let's say x was 1, just to understand what's going on. And by the way, after we finish these computations, I'm going to do it graphically, so just to show you what I'm going to show you now. Okay, so if x was 1, what is the absolute value of 1 minus t? Now for this particular integral, because I'm integrating from negative infinity to 0, so the t values are negative. If the t values are negative, then 1 minus t is going to be positive, right? So this is going to be positive, and in that case, the absolute value of 1 minus t is just 1 minus t, right? So the integral from negative infinity to 0, in this case, in this particular case, if x was positive, then you just get rid of the absolute value without changing anything. However, if x was, for example, negative 5, you will have the absolute value of negative 5 minus t. But unfortunately, so you're talking about negative 5 here, minus t. Now negative 5 minus t, sometimes it will be positive if t was here, but sometimes it will be negative if t was here, because the t values now are ranging from negative infinity to 0. So it is clear that for this integral, it is very clear for this integral that we need to do this integral for two cases. What are these two cases? So let's do some coloring to distinguish the stuff. So if x was positive, let me start with the easier case. If x was positive, now in this integral, because again I'm doing the integral from negative infinity to 0, so the t values in this example are less than 0. If t is less than 0, then we assure that x minus t is positive, right? Because x is positive, a positive minus a negative number is for sure positive. So in that case, the absolute value of x minus t is just x minus t, right? So now, so in this case, what happens is the integral from negative infinity to 0, e to the t, e to the minus absolute value. Again, with this case, if x is positive, this is going to be e to the t, e to the minus. What's the absolute value? It's the same thing. And this is an easy integral. So this is e to the t, e to the minus x, e to the t, dt. E to the minus x is a constant, e to the t times e to the t, e to the 2t over 2 from negative infinity to 0. And please remember, these are improper integrals. So if we are teaching a calculus 2 course, we would write the limit as x or t approaches negative infinity, but we assume we understand that. This is e to the minus x over 2. You substitute the 0, you get 1, minus you substitute the negative infinity, e to the negative infinity is 0. So in the end, we have e to the minus x over 2. So please, what is this? Just to write it in an easy way. This is the integral from negative infinity to 0, e to the t, e to the minus absolute x minus t dt, when what? This is when x is positive, okay? Okay. Now, remember, we go back. So we are computing the integral from negative infinity to 0 for this integral. We said we have two cases for x. If x is positive, this is what happens. Now we need to see what happens if x is negative. So now, if x is negative, let's see what happens. Again, we are doing the integral for t from negative infinity to 0. So x is negative, that means x is somewhere here. But the t values go from negative infinity to 0. So there could be anything here. Now, if t was in this area before the x, if t was in this area, in that case, the x minus t would be positive. But if t was on the other side, in this area, in that case, the x minus t will be negative, right? So in this case, the absolute value of x minus t is the same thing, but in this case, x minus t would be t minus x. So now we compute the integral. We need to do the integral from negative infinity to 0, e to the t, e to the minus absolute value of x minus t. But this time, we need to split the integral. Okay, we are going from negative infinity all the way up to 0, but in the middle, there is the x where things are changing about the absolute value. So this becomes from negative infinity to the x, e to the t, and between negative infinity and x, what's the absolute value? So this is the first equation we're talking about. The absolute value is x minus t, so this is this. Then a plus from x to 0, e to the t, e to the minus. Now what is the absolute value of x minus t? It's t minus x. And we compute this integral. So this becomes from negative infinity to x, e to the t, e to the minus x, e to the t. From x to 0, e to the t, e to the minus t, e to the x. And these are always easy integrals. So this is e to the minus x, e to the 2t over 2 from negative infinity to x plus e to the x times t from x to 0. So if you substitute the x, this will be e to the minus x over 2 times e to the 2x minus 0 plus if you substitute, this is what's going on. So this is e to the x over 2 minus x e to the x. So what is this? This is the integral from negative infinity to 0, e to the t minus absolute value, and if x was negative. Okay, so what have we done? Again, we are computing the convolution of the function with itself. We ended up having this line here, the sum of these two integrals from negative infinity to 0 plus from 0 to infinity. We started with negative infinity 0, but to do that we had two cases. So for the first integral, we had two cases. If x is positive, the red lines. If x is negative. So now we need to do the integral, the other integral. So now I want to compute the integral from 0 to infinity for, so now let's follow the same writing. So now I want to compute the integral from 0 to infinity, e to the negative t, e to the minus absolute value of x minus t dt. Okay, again, I just copied the second line here, the second integral, sorry. Okay, so now we do this integral. Now how are we going to do it? It is the same thing. So now again, with the red, I'm going to write this. Let's start with the negative case. If x is negative, then for this case, x minus t is going to be positive because the t values are from 0 to infinity. This is what happens. Now the t values are from 0 to infinity. This is the t. So if x was negative, for sure if x was negative, the x minus t, sorry, I missed this. So if x was negative, because the t values are all positive, so in this case the x minus t is going to be negative because x is smaller than all values of t. And in this case, the absolute value of x minus t is going to be t minus x. So now, what is the integral from 0 to infinity e to the minus t, e to the minus absolute value, this. This is the integral from 0 to infinity e to the minus t, e to the minus. Now what is the absolute value of x minus t? It's t minus x. So this is from 0 to infinity, e to the minus t, e to the minus t, e to the x dt, which is e to the x, e to the minus 2t over 2 from 0 to infinity and over negative 2. So this is e to the x over negative 2. If you substitute the infinity, you get 0. If you substitute the 0, you get 1. So after all, this is e to the x over 2. So what is this? This is 0 to infinity, e to the negative t, e to the negative x minus t dt when x is negative. Okay? Remember, so we are doing this integral, the boxed integral from 0 to infinity. So we did the first case, what happens when x is negative. Now we need to see what happens for the same integral, but when x is positive. So now if x is positive. So now what's going on here? Here the t values again are from 0 to infinity, so these are the t values. And the x is somewhere on this red line. So sometimes in this area, the x minus t is going to be positive, but in this area, the x minus t is going to be negative. So it is very clear that when we do this integral, we need to split the integral from 0 to x. And in this case, the absolute value of x minus t is the same thing because it's going to be positive. Then from x to infinity, this is the second half here. So this is e to the minus t, e to the minus, and what is the absolute value of x minus t? Because x minus t is negative, that's going to be t minus x. So it will go back to x minus t. So this is basically from 0 to x, e to the minus t, e to the minus x, e to the t. From x to infinity, e to the minus 2t, e to the x dt, which gives us e to the minus x times x minus e to the x over 2 and e to the minus 2t from x to infinity, which is just standard computations. So this is the integral from 0 to infinity, e to the minus t, e to the minus, when x is positive. Okay, so now we've done all the computations needed for this integral for the convolution, but now we need to add the 4 cases we have. So remember the convolution. So now I'm going to write it this way. So now the convolution of the function with itself, what is it? It's the integral from 0 to infinity, e to the t, e to the minus absolute value x minus t dt, plus, from negative infinity to 0, plus from 0 to infinity, e to the negative t, e to the minus absolute x minus t dt. And now we did all the integrals here, okay? But when we did the negative infinity 0, let's go back. When we did the integral negative infinity 0, we had 2 cases. This is one of the cases. So when x is negative, we had something, and when x is positive, we had something. The same for the other integral. So it is very clear that we need to split our answer for when x is negative and when x is positive. So when x is negative, what is the first integral? So we go back to the integral from negative infinity to 0 when x is negative. What is it? This is it. E to the x over 2. So this is e to the x over 2 minus x e to the x. And then for the second integral, so this is a plus, what is the integral from 0 to infinity when x is negative? It's e to the x over 2. On the other hand, what's the integral from negative infinity to 0 when x is positive? So we need to go back. Integral from negative infinity to 0 when x is positive, this is it. It's e to the minus x over 2. Plus, what is the integral from 0 to infinity when x is positive? This is it. It was the last integral we did. So it's x e to the minus x plus e to the minus x over 2. And we just simplify this. So this becomes e to the x minus x e to the x when x is negative, and e to the minus x plus x e to the minus x when x is positive. The equality, you can add it anywhere because the convolution, as we mentioned in the previous video, the convolution is always continuous. So you should not be worried about where the negative sign is. Okay, so this is how we compute the convolution. And now, as I promised in the beginning of the example, I want to show you for this particular function, e to the minus absolute value of x, the convolution with the same function. I want to show you the graphics behind all these cases. Okay, so we did kind of 4 cases, let's say. So let's see all the graphics. The idea is, so you draw the function e to the minus x. One of them, you just draw the function itself. So this is the function e to the minus t. Okay. What about this? Because we have two. Okay, it's the same function. But on the right, the formula is e to the minus t. On the left, the formula, so the colors are very important now just to distinguish all the cases. On the left, it's e to the t. Okay, so this is my first function, the function itself. Now, what is the other function? The other function is the function itself, because in this example, we are finding the convolution of f with itself. So the other function is the same function, but reflected through the y-axis. So now I want to reflect it. But when you reflect it, if you agree, you get the same thing, right? Then you start shifting it. So how do you shift it? Just imagine this. You shift it to the very left. You go to the very left and you draw it. So if you draw it, this is what's going to happen. You will have a function like this. Just the same, imagine copy-paste this function. The blue-green curve, just copy it and shift it back by x units. So instead of having it at 0, you will have this. So in this case, so just imagine, now here you have, again, 2 formulas for the function. What do you mean by 2 formulas of the function? Of course, this continues. This function continues like this all the way. Okay, so this is the case when x is negative. This is exactly what happens. So what is this red curve? What is it? It's e to the minus absolute value of x minus t, which is basically e to the minus x minus t when x minus t is positive, and e to the t minus, e to the minus t minus x when x minus t is negative. So this is equal to e to the t minus x when t is less than or equal to x, and here when t is greater than or equal to x, and this is e to the x minus t. So basically this is the t is less than or equal and the t is bigger than or equal to x. This is exactly how we look at this. So this is x, this is x. When t is less than x, so in this area the function is e to the t minus x, but on the other area, on the other side, the function is e to the x minus t. And now you say, okay, I want to multiply the red curve with the blue-green curve. So what happens is this. To the left of x, when x is negative, to the left of x, you just multiply e to the t with e to the t minus x. When x is negative, you multiply e to the t minus x, this red curve here, with this curve, which is e to the t. And to the right, what happens? You multiply this curve, which is e to the x minus t, you multiply it with e to the t all the way up to 0. But after 0, things change because the blue curve is no longer the blue curve, it becomes the green curve. So when you exceed the 0, when you cross the 0, the red curve stays as e to the x minus t, but the upper curve is not e to the t, it's e to the minus t. So then you need to change. So this is why we have this change at 0. So this is the explanation of the first splitting in our integral. So if we go back to the integral, the first thing we did, we split from negative infinity to 0, from 0 to infinity. But then the cases x is positive and x is negative. Why do we have these cases? Because again, if x is negative, this is what happens. But if x was positive, so imagine the x was here, so you have the same function but this way now. Okay. Now what is this? This is e to the x minus t, and this is e to the t minus x. And you want to multiply. So if you agree, if you go to the left, you multiply the red curve, which is e to the t minus x, with e to the t, all the way up to 0. But then after 0, you multiply the red curve, this part of the curve, e to the t minus x, with the green curve all the way up to x. And after x, you multiply e to the minus t with e to the x minus t. So these are the different cases that we have seen in our computations. So sometimes I know that some people, they prefer the graphics to understand the split of the integral, and some people like the way we did it before, but both are fine and they both explain things in different ways. I hope this makes it clear for the convolution of this function.